Okay, does everybody have their worksheets out? We're going to do number 3. I got it. Okay, what does it say for number 3? Hydrogen phosphate. Okay, so there's 2 ways to do this. One that is actually what the real world it looks like, and one that's acceptable for our purposes in this class. So let's just do it, and then I'll explain the other one, whichever way we end up. So, what do I start with? Hydrogen phosphate. So I got it up here. We're good. What next? I have to write it out. So P, write down phosphorus first. Hydrogen. Okay. Okay. Here, this is how I would go about it. So, I know that since it's in brackets, I know it's not in brackets on yours, but I had told you guys to bracket it if you need to. The phosphate, excuse me. The phosphate, that we know that the phosphorus and the oxygen have to stick together. They cannot be on separate areas. So I'm going to start with phosphorus because that's probably, if I had to guess, my central ion, or central element. How many electrons are on a phosphorus?
There is 5.
5. Okay? And then my oxygens. We know that my oxygens have to go around the phosphorus because they're stuck together. So, where would I stick the 4th one? On top? Yep. I am recording. Cool. Okay. How many electrons does oxygen have? 6. 6 apiece. Okay, for this top oxygen, where should I put my dots? I've got 2. I'll put the other 2. So I got 4. I need 2 more. On the bottom? Sure. That would create a what? It'd be a double bond. And so let's finish it out, and then I'll talk about it. Where should I put my hydrogens? Where's a spot where I can stick my hydrogens at?
Right there.
Right there?
Sure.
Sure. Next one. Next one. This one?
Sure.
Right? Because it has an opening.
Yeah.
It needs one. Okay, and I'm going to finish it out. Okay. This is what it looks like in nature. But count how many electrons the phosphorus has. 2, 4, 6, 8, 10. We've got 10. Yeah, right? Silly. So, we told you that they all want 8, so I would be okay if you decided to stick your electrons up here for the oxygen and create a single bond, and then there is 8 around the phosphorus. The reason phosphorus can do this, don't get too caught up on it, it's just the reason it can do it, is because what row is phosphorus in? Third. It's in number 3. Absolutely. So, what's the first D block? What's the first D block row? What do we call that? It's blank D10. What's the first? 3.
3d10.
So it's in the 3rd orbital, but it comes in the 4th row. The reason phosphorus can have 10 is because of that that D block. Does that make sense? Don't get too caught up on it. I'm just explaining that phosphorus can have 10. And actually, so can sulfur and chlorine, but don't do it. The only reason I say that is just for your own information. I'm okay if you put them here or you put them here. Up to you. If it lets you sleep at night and you put them like this, that's fine. If you want to do it actually, you can put them up here. Is that cool? Everybody make sense to everybody? Okay, excellent. You don't have to. Do as you please. I'll count both right. So if you put the electrons up here or down here, up to you. Because this is what exists in nature. If it's down here, this is acceptable for us.
Can we do the ones where this has one for,
Like I2?
Yeah.
Yeah. Okay. I2's on there, isn't it?
Yeah.
Excellent. I2. How many electrons does iodine have?
7, yep, 7.
How many iodine do we have? Seems to be a real nice spot that fits there.
That's just odd.
I'll go E. Everybody's got 8? Right? Good. Yep, that's how you do it. In naming that, it would just be iodine. Just iodine. If it's dine. So, oh, excuse me. I'm sorry. Iodide. Yeah, I know.
So how do I spell it? I-O-D-I-D-E?
No, okay. I'm sorry. No, I was right the first time. Yep. Okay. 4. The way it's spelled, when this is called a diatomic molecule, means when they have 2 of the same atoms. When you have a diatomic molecule, you will just name it the name on the periodic table. Chlorine, there'll be 2 Cl's, it's just chlorine. And that'll actually be how it exists in a gaseous state. It's hydrogen phosphate. Yep. You name it. So, yep, that's a good question. H2P, H3, excuse me, H3PO4. You just name it hydrogen and then phosphate.
So how do we know when to switch it? Like whenever we switch it unless it's alone, then it's okay if it's alone?
If it's alone, yep. If it's just H2, it'll be hydrogen. This is hydrogen phosphate. Yes. Yes. Good question, guys. Let's pay attention. Good question. Just so if you remember, I mentioned this a couple times. It's okay. S block elements are okay with having just 2. Okay. They're okay with just having 2 in their outer electron, their outer orbital. Okay? And this has to do hydrogen. Okay. We are going to, is everybody cool with what we're doing on your worksheet right now? What's the hang up on that? Like you're getting it, you just need more practice kind of stuff?
Yeah, I just need a lot
Okay.
of time to do it.
Would you rather have your own, do it on your own? Okay. And then I'm going to talk about something a little different, but same sort of business. Let's see if I can find it. Oh, I forgot to email her. Okay. Okay, we are going to talk about, can I erase this? You satisfied with this? That's just H3PO4. You have that on there. Yep, I'll hang tight. Okay. Excellent. So, we're going to talk about electronegativity and atomic radius. So, pay attention, hang tight, it may be confusing. Okay? So, we're talking about atomic radius and electronegativity. And this is more of this topic at a glance rather than an in-depth observation of it. Okay, so we have, let's take hydrogen. Oh, that's helium. My bad. Okay, so we have hydrogen. What's a nucleus made out of? What's in the nucleus? Nope. Nope. Protons and neutrons. In the nucleus, so I'm going to draw a nucleus. What's the nucleus? Does anybody know what the nucleus is? Of an atom. Nucleus of an atom. It's the center. It's the center of an atom. And what's on the outside? What orbits around the nucleus? Electrons. Yep. So I'm going to draw this. This is our first valence shell. We're talking about hydrogen. How many electrons does a hydrogen have? One. Right here. And it's just going to float around. It's going to, I don't know how to illustrate floating around, but it's just kind of orbit, circle around. And it really likes to be here. Why do you think it likes to be here? Think of the electrostatic force. Anybody remember the electrostatic force?
Not really.
No? It's that like charges do not like to be next to each other. So give me an example of a like charge being next to each other. Yep, two positives or So if I were to make helium, how would I make that helium? That's helium, right? Would these two electrons be right next to each other? Think of an electrostatic force? No. They'll try to stay away from each other. Absolutely. So